Okay, retro, go. Vital, go. Guide, go. Control, go. Telcom, go. GNC, go. Econ.
Although humans have always been fascinated by and intrigued by the moon, lunar research really got underway in the 1950s when robotic spacecraft were developed and launched by the USSR and the US. The first spacecraft to pass past the moon was Lunar 1, launched by the USSR in 1959. The first soft landing was accomplished in 1966 by Lunar 9, while the first human landing was accomplished by U.S. spacecraft Apollo 11 in 1969. Numerous countries have contributed to lunar orbiters and landers in the decades afterward. 5 countries have accomplished successful moon landings as of January 2024. Even with these amazing accomplishments, one part of the moon remained unexplored, the far side. The far side of the moon is mysterious since it is never facing Earth and is completely hidden, giving rise to the false moniker dark side, which implies that sunlight never reaches its surface. That is the area of the moon that we will never be able to visit unless we take a spacecraft and travel there. However, we can now see what's beyond the horizon owing to the James Webb Space Telescope, ushering in a new age of lunar exploration and discovery. Come us as we explore the enigmatic far side of the moon, revealing hidden secrets and showcasing some of the lesser-known aspects of our cosmic friend. Whatever you see on the lunar surface, a face, a bunny, a toad, or something else entirely, we are all looking at the same side of our natural satellite. What prevents us from ever seeing the moon's far side, then? Let's take a closer look at its connection to Earth to find out why. The lunar orbit is characterized by a rotational period that is almost equal to the duration of the Earth's orbit. In other words, the moon does one full rotation on its axis while circling our planet. During its orbit, one side of this remains facing us. Tidal locking is the technical term for this type of spin-orbit lock. The moon does, of course, have a dark side, albeit it's not always the same side. Whichever phase of the moon we are viewing determines what is shadowed. The side of the moon that is ordinarily illuminated by the sun from here on Earth is in shadow when the moon is young because it is positioned between Earth and the sun. That area of the surface is only illuminated when the moon is in opposition to the sun. The far side is thereafter completely dark and shaded. The far side of the moon used to be secretive and enigmatic, but that all changed in 1959 when the Soviet Union's Lunar 3 spacecraft gave us our first view of it early in the space race. Sputnik 1 was a primitive spacecraft by today's standards, but Russian engineers managed to get it into orbit around the moon just 2 years after it was launched. We had our first clear view of the enigmatic far side. Lunar 3 collected a total of 29 film photos of the far side, which were processed, repaired, and dried on board using photographic processes. Keep in mind, this was before the days of multi-megapixel cameras. The film that was utilized was, ironically, taken from American spy balloons since it needed to be radiation-hardened and robust. The processed pictures were spot-scanned from the photos back to the receiving station in the former Soviet Union using a rudimentary onboard scanner. The spacecraft employed a mix of 2 camera systems, one broad field and one narrow field, but with greater resolution. They proved to be a revelation, even though only 17 of the 29 captured were successfully communicated back to Earth, of which 6 were deemed acceptable enough for publishing. The lunar surface was seen from a completely different angle thanks to those 6 photos, which revealed 70% of the far side. The black splotches that form the man and the moon visage on the near side are nearly entirely gone from the far side, as was almost immediately apparent. These dark areas are called Maria, and they are basaltic plains that were formed on the moon billions of years ago by volcanic activity. Rather, the far side was much more cratered than the near side, with some of the craters reaching the size of small nations. In what was considered to be the height of the Cold War era, the Soviets began identifying many of the characteristics they were seeing for the first time, an act that sparked considerable controversy. The faintest trace of Mare Orientale, one of the biggest impact craters ever observed on the moon's limb, gave us a sneak peek into one of those enormous new craters, which is really one of the very few Maria on the far side. When that part of the moon swings around towards us during excellent librations, it may be seen. It has been known since Julius Franz discovered it in 1906. The image of Oriental impact crater from Luna 3 demonstrated its immense size, like a bullseye. It was created by an asteroid collision estimated to have been 64 kilometers broad just less than 4 billion years ago. At over 900 kilometers in diameter, it was roughly the length of the United Kingdom, give or take. Volcanic lava later filled the enormous crater that resulted, known as an impact basin. Another Soviet mission, Zond 3, visited the Moon in 1965. Unlike Luna 3, Zond 3 had a significantly superior camera and could do more in-depth scientific studies, such as spectroscopy. Zond 3 captured 23 incredibly detailed images of the lunar far side, allowing for the creation of one of the earliest comprehensive maps of the whole Moon. Meanwhile, NASA was making incredible progress with the Apollo program. President Kennedy had declared that the United States would send a man to the Moon and safely return him to Earth by the end of the 1960s. By December 1968, NASA was prepared to send 3 people on the Apollo 8 mission: Frank Borman, Jim Lovell, and Bill Anders. They made history by being the first people to sight the elusive far side of the Earth and to escape from low Earth orbit. This is how Lovell famously described the lunar surface: the Moon is essentially gray, no color, looks like plaster of Paris or sort of a grayish beach sand. We can see quite a bit of detail. There's not as much contrast between that and the surrounding craters. The craters are all rounded off. There's quite a few of them. Some of them are newer. Many of them look like, especially the round ones, look like they were hit by meteorites or projectiles of some sort. The communication to Earth was lost for around 10 minutes as the Apollo 8 spacecraft circled the Moon's far side. The aircraft crew and mission control were both terrified during this signal outage. Apollo 8 was traveling to a place where no human had ever gone before, completely isolated from Earth. Many members of the flight crew at Mission Control in Houston exhaled in unison when the astronauts returned from the far side. "The computer told us that we were out of contact with the Earth and that we had loss of signal," says Charlie Duke, the Apollo 16 lunar module pilot. "Then all of a sudden there was the sunrise. It was the most dramatic sunrise I've ever seen in Earth orbit. You see the sun's glow on the horizon or the planet's atmosphere, and it gets brighter and brighter, but the Moon is different. There's instant sunlight with long shadows on the lunar surface. The far side of the Moon was very rough back there. I would not have wanted to land on the backside of the Moon." 2 months before the dramatic landing of Apollo 11, in May 1969, Gene Cernan, John Young, and Tom Stafford were the next astronauts to explore the far side of the Moon on board Apollo 10, which returned to low Earth orbit testing of the lunar module following the success of Apollo 8. However, during Apollo 10, the 3 astronauts saw something unusual while flying over the Moon's far side. This encounter has caused NASA to re-explain in recent years because of conspiracy theory films that have been showing on U.S. television. Since the 1970s, the facts have been widely known. Some really peculiar noises were the manifestation of these weird happenings on Apollo 10. Although cutting edge at the time, the radio systems aboard the Apollo spacecraft were outdated by today's standards. Most astronauts said that the command and lunar modules were noisy places, with loud bangs and bumps mixed in with the sound of fans and engines. The crew of Apollo 10 was confused by what they heard over the radios. Although research has since shown that the sound was nothing more than an interference effect from those 1960s radio communication systems on board, they described it as sounding almost like the sound made by an electronic instrument called a theremin, which was often used in creepy science fiction B-movies of the 1950s and 60s, as well as in the Beach Boys song Good Vibrations. As the moon landings began, 2 astronauts descended to the surface, and the 3rd astronaut stayed in the command module to circle the moon by itself. The solo orbiting missions of Michael Collins, Apollo 11, Dick Gordon, Apollo 12, Stuart Roosa, Apollo 14, Al Worden, Apollo 15, Ken Mattingly, Apollo 16, and Ron Evans, Apollo 17, were among the bravest feats ever accomplished by astronauts, even though they all had the opportunity to orbit the moon and see the far side before landing. From orbit, they would chart features that no one had ever seen before, spending days performing meticulous inspections of the moon. Al Worden is frequently cited as stating that during the Apollo 15 mission, his alone time was among of his best. As said by Worden, the far side, the views at certain times when the sun and the earth are blocked out, are like nothing you could imagine. The sheer number of stars you see is incredible. It's like a sheet of white, and you know that every single one of them is a sun in its own right. Why all of the Apollo missions were limited to the near side is a subject that is frequently posed to the astronauts and flight crews. The solution is really easy to understand. If something had gone wrong while the astronauts were on the surface, they would not have been able to connect directly with Earth. As Charlie Duke states, we wanted to be in contact with the Earth. Nowadays, this wouldn't be an issue as communication could be relayed via satellites positioned in lunar orbit. Scientists are becoming more interested in the far side, maybe because of upcoming human trips. Yes, there are a lot of options for the moon's far side. The scientific and astronomical community has advocated for the placement of radio and optical telescopes on the far side for many years. Far-side observatories would be protected from both the glare of daytime on Earth and man-made radio interference from Earth. The telescopes would provide us an unparalleled level of clarity and understanding into the farthest regions of the cosmos if they were constructed inside craters to protect them from solar radiation. Furthermore, our comprehension of the mechanisms underlying the striking dissimilarity between the near and far sides' appearances is limited. The rise in interest in lunar exploration is fantastic news for planetary scientists wanting to discover more about Earth's rocky body, and with NASA preparing to send people to the moon's south pole, there has never been a better moment to be a lunatic. They are eager to respond to these pressing inquiries. As a project scientist for the Lunar Reconnaissance Orbiter and research scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland, Noah Petro states that the fundamental question of how the moon formed and how that relates to the Earth is really the most important of the unknowns. Everything else comes after that. We can thank Apollo 11 for providing us with our first glimpse into that mystery. Decades of research aimed at understanding the formation and evolution of the moon were started with the mission, which also returned with 50 pounds worth of moon rocks. Using these fragments, scientists created the most convincing model yet for how the moon formed, a massive sphere of molten lava around Earth. This gave rise to the theory that the moon originated on Earth when debris from a massive impact with an asteroid the size of Mars was sent into orbit. This theory is further supported by research on the rock, which reveals that the same stuff that generated the moon also formed our planet. Though it's not perfect, that is the most frequently accepted theory of the moon's origin. The moon was not formed by a massive impact, and our understanding of how the lava ocean cooled to become the dry gray rock that we see today is still quite incomplete. It's a little challenging to explain the discovery of water traces on the moon around a decade ago with the impact theory. Investigating the moon's past necessitates the same kind of fieldwork as our efforts to understand Earth's past. Setting aside the question of how the moon came to be, Apollo moon rocks pose another puzzle that begs for explanation. Why aren't moon rocks older than the moon itself? The moon is only 60 million years younger than the solar system, having formed slightly over 4.5 billion years ago. The planetary accretion process, which forms larger and larger entities over time, is the result of solid objects colliding constantly as they whirl about the young sun during the turbulent early stages of the inner solar system. Almost none of the rocks that the Apollo astronauts gathered were dated to the first 600 million years of the moon's existence, but analysis indicates that the majority were formed by impact events some 3.9 billion years ago. This is strange since when planetary accretion slowed down, impact occurrences ought to have decreased in frequency. Therefore, a lot more rocks generated from previous impacts should be found. This prompted scientists to postulate that around 3.9 billion years ago, during the late heavy bombardment, or more poetically, the lunar cataclysm, the moon was the target of violent impacts. Although this explanation explains the Apollo moon rocks rather well, it begs a significant question: why did all these pebbles begin to fall on the moon? According to the dominant concept, the outer planets once orbited considerably closer to the Sun and sent large pebbles hurtling at the Moon as they drifted outward. On the other hand, another hypothesis claims that the majority of rocks with an estimated age of 3.9 billion years ago is the result of sample contamination and that the deluge never occurred. Imum Serenitatis and Nectaris are the two largest impact craters from which samples were collected by the final 3 Apollo missions. Recent data indicates that the materials used to estimate each crater's age, a critical step in establishing whether or not a period of intense bombardment had place, may just be remnants of the impact that created Imbrium, the biggest crater, some 3.9 billion years ago. Therefore, visiting craters like the South Pole or the far side of the Moon, where samples are unlikely to have been tainted by the Imbrium impact, will be the best method to resolve the lunar catastrophe argument. Scientists will be able to better comprehend circumstances in the early solar system and seriously challenge the notion of the lunar catastrophe if the majority of those new samples are older than 3.9 billion years. That being said, scientists are primarily interested in the lunar South Pole as a landing location because they are aware that lunar water exists there. Yes, the Moon does contain water. Not only a little bit of interplanetary water, but water was discovered on the Moon for the first time by NASA in 2009. We are talking about potentially hidden treasure troves of water ice, particularly around the lunar poles. This is fantastic news for upcoming lunar missions that want to exploit this water ice for rocket fuel and life support. However, the main concern of several experts is the question of how all that water ice got there. As of this moment, no one truly knows. Paul Hayne, a planetary scientist at the University of Colorado Boulder, has 3 basic ideas on the Moon's water origins. The most widely accepted explanation holds that water ice was left behind after comet and asteroid strikes, where it evaporated and ultimately traveled to the poles. It's also conceivable that variations in surface temperature caused ionized hydrogen from solar winds to bond with oxygen held in regolith and finally evaporate as vaporized water. The last option is that water may have been a component of the material that created the Moon's initial composition and was driven to the surface by volcanic eruptions. It's possible that all 3 processes were involved, in which case the question becomes how much water was added by each method. Fortunately, preliminary evidence has been encouraging. NASA launched the Lunar Crater Observation and Sensing Satellite in 2009 with the goal of making an impact on the South Pole lunar surface. In addition to finding evidence of water, this expedition also found a combination of other elements frequently seen in comets, indicating that at least some of the water may have traveled across space on rocks. It will be essential to dispatch a robot or person to collect a sample and analyze its isotopic makeup in order to gain a better understanding of the proportion of the Moon's water that was carried to the surface by comets, asteroids, or solar winds. That's basically the only way we can link that content to a source with absolute certainty. The puzzle of how lunar water got to be concentrated in the poles remains, even in the event that scientists are able to identify its source. Hayne claims that the question of whether water evaporated after comet and asteroid impacts can migrate over the Moon's surface or if it gets stuck in the regolith is a contentious one that divides the lunar research community. Returning for more testing is the only surefire method to find out. Is there extraterrestrial life on the Moon? Is one of the main questions lunar scientists have. Aside from little green man conspiracies, some scientists think ancient bacteria might be present in the water beneath the satellite's surface. Astrophysicist Professor Christopher Palma of Penn State suggests that comets may have carried the building components of life when it first began. Remaining parts of them could exist in the Moon's ice. Until a probe or person is sent to the lunar surface equipped with a powerful drill, scientists won't be able to say for sure. The finding that something big is hiding beneath the Moon's south pole, behind the greatest impact crater in the solar system, is one mystery that has only lately come to light. Its nature is unknown to science, but its size is guaranteed to have an impact on the Moon's mass's gravitational pull. Most ideas propose that it is a hefty metal body from a long-gone projectile strike on the surface. However, this is far from definite, and it's unclear why this mass is hung below the surface. Heat should have forced this material to move, not remain imprisoned like Han Solo and carbonite, given we know that the moon's interior is still somewhat active. In other words, the moon poses issues that we just cannot answer. Another startling discovery revealed that there are regular earthquakes on the moon. Seismometers from the Apollo period that were erected on the surface recorded these vibrations, often referred to as moonquakes, between 1969 and 1977. According to this research, the moon is a dynamic body rather than the dead, stale rock that many people believe it to be. A handful of the factors that trigger these earthquakes are already known to us: thermal expansion, tidal stress caused by Earth's gravity, and collisions from meteorites. However, we are unsure of the precise behavior of the earthquakes and how these mechanisms operate due to the paucity of available data. In addition, certain shallower moonquakes appear to be happening more recently than the others and have no apparent explanation. A worldwide seismic network erected around the moon, according to Pro, would be quite beneficial in figuring out the trigger mechanisms underlying all of this tectonic activity. A network like this could clearly pinpoint the precise time these events happened, their source, and their impact on the moon's surface. Our current data, which is 50 years old, is insufficient to provide us with useful answers. Furthermore, researchers think there's a reason why we've only ever seen one side of the moon. Because of its tidal locking, only one side of it is facing Earth. Although it is typical for moons in our solar system to do this, it is still unknown exactly when, under what circumstances, or how it happens. Thus, to some scientists, the riddle of tidal locking is linked to the question of the moon's formation and the events of its early history. It adds another piece to the jigsaw of 4 billion years. Furthermore, this enigma extends beyond the moon. It's critical to determine what causes traits like tidal locking and determine whether potentially habitable worlds like the TRAPPIST-1 exoplanet are indeed conducive to life, as we continue to discover additional planets and moons outside of our solar system. After all, we might be able to learn more about the history of the solar system if scientists can solve some of the riddles surrounding the moon. The moon's surface hasn't altered much throughout the ages since it doesn't have much of an atmosphere and hasn't had volcanic activity in billions of years. Paul Saxon, a postdoctoral researcher at NASA's Goddard Flight Center, compares the craters to the pages of an early solar system history book in this way. If only we could learn how to decipher them. As previously stated, a widely accepted explanation about the birth of the moon states that approximately 3.9 billion years ago, space objects attacked our planet's neighbor. We may learn a great deal about the formation of the solar system if the surface samples verify the existence of a lunar catastrophe. It would imply that not only were the outer planets formerly a lot closer to the Sun, but that Earth was also probably blasted. Any water on Earth's surface would have evaporated as a result, wiping out any potential life. Ironically, it also seems that the moon has preserved early solar history. A few years ago, Saxon and colleagues concluded that during the first billion years of its existence, the Sun probably rotated 50% slower than comparable newborn stars based on the chemistry of the lunar crust. Although the moon has far less sodium and potassium than the Earth, the two planets are essentially made of identical components. Saxon and his colleagues used this data to run models that demonstrated how solar activity may either deposit or remove these minerals from the moon. They then included information about the correlation between star rotation rates and solar flares. Based on the simulations, it appears that the Sun's rotation speed was slow enough to explain the current moon's potassium and sodium levels. This information about the early history of the Sun can also help explain how rapidly the atmosphere of Mars and Venus was destroyed, as well as how it affected Earth's atmospheric chemistry. Additional significant concerns will need to be addressed when NASA and other space organizations establish the framework for a long-term human presence on the moon. In reality, the moon is really a minor step on the path to discovering the genesis of all that we know. That's all the information we have for you today. Share your opinions in the comments below. Thanks for watching another episode. While you're here, you can watch more space-related video.